Students and friends, in this video we are going to discuss about post-fertilization events. Now, what do you mean by post-fertilization events? The events which take place after the process of double fertilization is known as post-fertilization events. In post-fertilization events, formation of endosperm and embryo, development of seed from ovule and development of fruit from ovary are incorporated. That is three things: development of endosperm and embryo, formation of seed and development of fruit. They are included in post-fertilization events. We have studied that during the process of fertilization, that is double fertilization, we got two structures. The first one is known as zygote, which is the result of syngamy, and second one is primary endosperm nucleus, which is the result of triple fusion. Primary endosperm nucleus will give rise to endosperm. Zygote will give rise to embryo by the process of endosperm and embryo development respectively. We know that primary endosperm nucleus is triploid in nature, whereas zygote is diploid in nature. First of all, we will study about the development of endosperm from primary endosperm nucleus, which is triploid in nature. See what happens if we see the female gametophyte inversely. Inversely means here the zygote is located and here the primary endosperm nucleus is located. In this case, which is given in your textbook, all the diagrams are given in your textbook. So primary endosperm nucleus, first of all, will divide continuously to give rise to number of nuclei. It is a kind of nuclear division, completely nuclear division. That means there is no possibility of cytoplasmic division. So number of nuclei are produced. So it is known as free nuclear endosperm. Why it is so? Because the endosperm is made up of numerous nuclei. Now what happens? Now the nuclei start to move towards the periphery, and inside the female gametophyte, in the middle of the nuclei, a large vacuole is formed. Now cytoplasmic division occurs. And so that the nuclear or free nuclear endosperm is converted into cellular endosperm. So there are three different types of endosperm development. First one is free nuclear type. Second one is cellular type, and in the kind of endosperm development where both kind of stages are observed, free nuclear as well as cellular, it is known as halobial kind of endosperm development. Now, this is endosperm or endosperm tissue. It is rich in nutrients, and the function of endosperm is to provide nutrition to the developing embryo. So what will happen in future? The zygote will develop into an embryo. the embryo moves towards the endospermic region of the seed or female gametophyte, and then the nutrition will be provided to the developing embryo. Also, we have studied that the free nuclear endosperm is converted into cellular endosperm respectively after cytoplasmic division. I think you have seen the coconut. The coconut, when we cut it from the inside, we will be able to observe coconut water. And coconut water is nothing but, it is the best known example of free nuclear endosperm. Whereas the white kernel outside it is nothing but the cellular endosperm. So as the coconut water amount decreases in the coconut, the thickness of the kernel increases. That means the free nuclear endosperm of coconut is being converted into cellular endosperm. So this was all about the development of endosperm. Now we will discuss about the development of embryo from the zygote. As I told you earlier, the zygote is located near the micropylar end of the ovule. And see, this is zygote. This is female gametophyte. Just imagine virtually. Now what will happen? The first division will be transverse division of zygote, and so that two different nuclei are produced. Two different cells, different sized cells are produced. The smaller one is known as apical cell, and the larger one will be known as basal cell. Now apical cell will undergo longitudinal division, whereas the basal cell will undergo transverse division. And as a result, how many cells are produced? 4 cells. 2 apical and 2 basal cells. These 4-celled structure of embryo is known as proembryo. It is known as proembryo. Now what happens? The middle basal cell will undergo continuously numerous transverse divisions, and as a result, what will happen after some time? A long, slender, rod-shaped structure is produced, which is made up of 20 to 25 cells. This structure is known as suspensor. And what is the utilization of the suspensor, or the function of suspensor? We have studied that here. Endosperm is produced. So when suspensor is produced, suspensor is formed, the apical cells which are responsible for the formation of embryo, they are pushed towards endosperm so they can get enough amount of nutrients. Now 2 apical cells will undergo into a longitudinal division. So 4 apical cells are produced, 2 on the front side and 2 on the back side. After some time, again a transverse division converts these 4 cells into 8 cells, which is 8 nucleated embryo, we can say. 4 on the front side, 4 on the back side. And then a periclinal division converts these cells into 16 numbers. That means 8 on the front side, 8 on the back side. And after some time, the development progresses, and then some time, a heart-shaped embryo will be formed, and then a complete developed embryo will be observed. So this is a kind of embryo development. This kind of embryo development is observed in Capsella and other angiospermic plants. And that's why this embryo development is known as Capsella embryo development. Now friends, let's discuss about the structure of typical dicot embryo as well as the embryo of grass family. This is the diagram, just concentrate over here. This is the diagram of typical dicot embryo. A typical dicot embryo contains an embryonal axis and two cotyledons. How many? Two cotyledons, because it is example of dicot embryo. And this is embryonal axis. The region of embryonal axis above the level of cotyledons is known as epicotyle. And region below to it is known as hypocotyle. Epicotyle contains a plumule, or in other words you can say shoot tip or primary shoot, whereas the hypocotyle contains a radicle or plerome or root tip, and root tip is guarded with the help of a protective layer known as root cap. Now concentrate on the second diagram, that is the embryo of grass. In this diagram, we have observed that two cotyledons are present because it is a result of dicot embryo. But here it is grass family, and grass family is a kind of monocot. So single cotyledon occurs on the outer side, which is a shield shaped, and it is called scutellum. Below the scutellum, you will observe again an embryonal axis. Below the scutellum, that is on the upper side, there again it is called epicotyle, and lower part is known as hypocotyle. Epicotyle consists of shoot apex and leaf primordia. And shoot apex and leaf primordia, which are responsible to give rise to new fresh leaves when the seed is sown into soil. Shoot apex and leaf primordia are again overlaid. They are protected by a protective covering known as coleoptile. And coleoptile is only observed in monocot embryos, not in dicots, absolutely. Whereas the lower part, that means the lower than the epiblast, the lower part is known as hypocotyle, and hypocotyle contains a long slender structure which is known as radicle, or in other words it is called plerome. The radicle is again protected by a protective covering known as root cap, and root cap as well as radicle, they are both controlled and overlaid by a protective covering known as coleorhiza. So friends, in this video we have discussed about two main aspects which are enclosed in post-fertilization events. One is endosperm development, another one is embryo development. Endosperm development, as we have discussed earlier, there are three types: free nuclear, cellular, and halobium. The example I have given to you is the endosperm of coconut. The water is example of free nuclear embryo, whereas the white kernel is the example of cellular embryo. Sorry, endosperms respectively. Slip of tongue of mine. Right. And we have discussed about embryo development. That is, embryo development is most of the dicots. See, the embryo development in monocots as well as dicots follow certain stages. And the primitive stages or the initial stages in the development of embryo in monocots as well as dicots are similar in most of the cases. And development of embryo is known as embryogeny. So it is quite common in monocots and dicots, irrespective of the nature, irrespective of the plant. And now we have studied the diagrams or the structures of typical dicot embryo as well as the embryo of grass. Right? Now, in the next video, we are going to discuss about the last topic, last few topics of chapter number 2, and that will be seed, that will be fruit, and that will be aponesis as well as